Hello everyone, in this tutorial you will create components of a bench vise and then assemble them as shown in figure here. You need to create all the components as separate files. Creating the folder. Before creating the components for the assembly, you need to create a folder with the name C07 under the casting folder in the data panel. Next, you need to create a folder with the name bench vise assembly under the C07 folder. Double click on casting folder in the data panel and choose the new folder button. Double click here, then click on the new folder button. New folder is created here. Then press enter key. Rename new folder to C07. Right click here. A shortcut menu is displayed here. Choose rename option from the shortcut menu and enter C07. Then press enter key. Similarly, create a folder with the name bench vise assembly under C07 folder. Double click here and then click on new folder button and rename this folder as bench vise assembly. And press enter key. Creating the components. The bench vise assembly will be created with the bottom-up assembly design approach. You need to create all components of this assembly separately and then save them with their respective names. First, create the base part of the assembly. Choose the Create Sketch tool from the Create panel of the Solid tab. In the Design workspace, the default planes are displayed in the Graphics window. Create base of the bench vise assembly on the desired plane using the dimensions given here. With the help of these dimensions and views, you will create the base of the bench vise assembly. But here you can see that I have already created base of the bench vise assembly by using the sketching and part modeling tools. Choose the Save option from the application menu. The Save dialog box is displayed. Click here, then choose Save option. Enter base in the name edit box. Enter base in the name edit box. Click on the down arrow on the extreme right side of the location selection box. The Save dialog box gets expanded. Click here. Choose the casting option from the project area. Next, choose the bench vise assembly from the casting C07 area. Choose the casting project from the project column. Now, choose bench vise assembly from casting C07 area. Choose the Save button to save the model and exit the Save dialog box. Click on the Save button. Similarly, create all the components of the bench vise assembly and save them on specific location. Similarly, you have to create all the components of the bench vise assembly with the help of sketching and part modeling tools and save them in the bench vise assembly folder. Here you can see that I have created all the components with the help of sketching and part modeling tools and saved them in bench vise assembly folder. Inserting components in assembly design. Choose the Show Data Panel button from the application bar if the data panel is not displayed by default. But here you can see that data panel is displayed by default. So you can skip this step. Double click on the bench vise assembly folder in the data panel. The bench vise assembly folder is opened. Double click on the bench vise assembly. Right click on the base in the data panel, a shortcut menu is displayed. Right click here. Choose the Insert into Current Design option from the shortcut menu displayed. The base is inserted in the design and the Move or Copy dialog box is displayed in the graphics window. Choose the Insert into Current Design from the shortcut menu. The base is inserted in the design and Move or Copy dialog box is displayed here. Keep the inserted component at its default location and choose the OK button to close the dialog box. Click on the OK button. Inserting and assembling the voice jaw. Next, you need to insert the voice jaw in the assembly design. Right click on the voice jaw in the data panel and choose the Insert into Current Design option from the shortcut menu displayed. The selected component is inserted in the assembly design and the Move or Copy dialog box is displayed along with the inserted component. Right click here, then choose Insert into Current Design option from the shortcut menu. Rotate the required manipulator by dragging it or enter required value in the angle edit box of the Move or Copy dialog box. Enter 90 in the Z angle edit box. Choose the OK button from the Move or Copy dialog box. Click on the OK button. Choose the Joint tool from the Assemble panel of the Design workspace. The Joint dialog box is displayed with the Position tab chosen. Also, you are prompted to place the joint origin on a component. Before choosing the Joint tool from the Assemble panel, you have to right click here, then choose Unground from Parent option from the shortcut menu. Click here, then choose Joint tool from the Assemble panel. Choose the Simple button from the Origin Mode area under the Component 1 node. Choose the Simple button from the Origin Mode area. Next, select the location on the white jaw where you want to place the joint origin. On doing so, Select button gets activated in the Snap area under the Component 2 node. Rotate the assembly with the help of the VQ. Then select this face. Select the location on the base to place the joint origin on a component. The white jaw gets assembled with the base and the joint dialog box gets modified. Again, rotate the assembly with the help of the VQ and then click here. Select the Motion tab of the Joint dialog box and then choose the Slider option from the Type drop-down in the Motion area. Select the Motion tab and then choose Slider option from the Type drop-down. Select the X-axis option from the Slide drop-down list to slide the white jaw on the base. Next, select the X-axis option from the Slide drop-down list. Choose the OK button from this dialog box. Now click on the OK button. Click on the Home button to get the isometric view of the assembly. Now you can see that white jaw gets assembled with the base. Creating contact set. Next, you need to create contact set between base and the white jaw. Choose the Enable All Contact tool from the Assemble panel. The new contact set tool is added to the Assemble panel and the Contact All node is added to the browser bar. Click here, then choose Enable All Contact tool from the Assemble panel. New contact set added here and Contact All node is added to the browser bar. Right click on the Contact All node in the browser bar. A shortcut menu is displayed. Right click here. Choose the New Contact Site option from the shortcut menu. The New Contact Site dialog box is displayed and you are prompted to select two or more components to create a contact site between them. Choose New Contact Site from the shortcut menu. New Contact Site dialog box is displayed here. Select base and vice jaw from the graphics window to create a contact between them. Choose base and vice jaw from the browser bar. Choose the OK button. In the New Contact Set dialog box, the contact is applied between the components. Choose the OK button. The contact is applied between the selected components. Next, assembling the jaw screw. Next, you need to assemble the jaw screw with the assembly. Right click on the jaw screw. In the data panel, a shortcut menu is displayed. Choose the Insert into Current Design option. The jaw screw is inserted in the assembly and the Move or Copy dialog box is displayed. Right click here. Then choose Insert into Current Design option from the shortcut menu. Choose the OK button from the Move Copy dialog box after repositioning the jaw screw. Reposition the jaw screw with the help of the manipulator. Then choose OK from the marking menu. Choose the Joint tool from the Assemble panel of the Design workspace. The Joint dialog box is displayed. Also, you are prompted to place the joint origin on component. Click here, then choose Joint tool from the Assemble panel. Choose the Simple button from the Origin Mode area under the Component node if not chosen by default. Choose the Simple button from the Origin Mode area. Select location on the jaw screw to place the joint origin on component. Rotate the assembly with the help of VQ. Then click here. Select location on the vice jaw. The jaw screw gets assembled with the vice jaw and the joint dialog box gets modified. Now click here. Choose the Motion tab of the Joint dialog box and then choose the Cylindrical option from the Type drop-down list in the Motion area. Choose the Motion tab and then choose Cylindrical option from the Type drop-down list. Select Z-axis from the Axis drop-down list. Select the Z-axis from the Axis drop-down list. Choose the OK button from the Joint dialog box. The jaw screw gets aligned with the central axis of the vice jaw. Click on the OK button. Now you can see that jaw screw gets aligned with the central axis of the vice jaw. Click on the Home button to get the isometric view of the assembly. You need to fix the jaw screw linearly. Invoke the Joint dialog box and choose the Simple button from the Origin Mode area. Next, select the face of the jaw screw. You are prompted to place a joint origin on the component. Click here, then choose Joint option from the Assemble panel. Next, select Simple button from the Origin Mode area. Now rotate the assembly with the help of the VQ. Then click here. Choose the Select button from the Snap area under the Component 2 node if not chosen by default. Choose the Select button from the Snap area. Select the location on the vice jaw. Rotate the assembly with the help of the V cube and then click here. Choose the revolve option from the type drop-down list of the motion tab and choose the OK button from this dialog box. The jaw script gets assembled with the vice jaw. Click here, then choose revolve option from the type drop-down list. Now click on the OK button. Choose the home button from the graphics window. Now you can see that jaw screw gets assembled with the vice jaw. Assembling the oval flister. Next, you need to assemble the oval flister with the assembly. Insert the oval flister in the assembly and reposition it in such a manner that there is no overlapping between the oval flister and the existing components of the assembly. Right click here, then choose Insert into Current Design from the shortcut menu displayed. Drag the oval flister with the help of manipulator. Then choose OK button from the Move or Copy dialog box. Invoke the Join dialog box. Click here, then choose Join tool from the Assemble panel. Select the edge of the oval flister as component 1 and the inner edge of the vice jaw as component 2. Rotate the assembly with the help of V cube. Then select this edge of oval flister. Again click on the home button to get the isometric view of the assembly. Now select this edge of vice jaw. Choose the rigid option from the type drop-down list of the motion tab and choose the OK button from the dialog box. The oval flister gets assembled with the vice jaw. Click here and then choose rigid option from the type drop-down list. Now choose the OK button. The oval flister gets assembled with the vice jaw. Assembling the screw bar and bar globes. Insert the screw bar in the assembly and reposition it if required. Right click here, then choose Insert into Current Design option from the shortcut menu displayed. Reposition the screw bar with the help of manipulator. Now choose the OK button from the Move or Copy dialog box. Invoke the Join dialog box. Click here, then choose Join tool from the Assemble panel. Select the face of the screw bar and select the cylindrical face of the hole of the jaw screw. Select the face of the screw bar and now select the cylindrical face of the hole of jaw screw. Choose the slider option from the type drop-down list of the motion tab. Click on the motion tab and then make sure that slider option should be selected in the type drop-down list. Select the Z axis from the slide drop-down list and choose the OK button from this dialog box. Make sure that Z axis should be selected in the slide drop-down list. Now click on the OK button. Insert two instances of bar globes in the assembly design from the data panel and reposition them so that its planar surface is toward the screw bar where it will be assembled. Right click here, then choose Insert into Current Design. Now reposition it with the help of manipulator. Right click here, then choose OK from the marking menu. Move it to here. Again right click here, then choose insert into current design. Reposition the bar globe with the help of manipulator. Right click here, then choose OK from the marking menu. Move the bar globe to this place in the graphics window. Click on the bar globe and move here. Invoke the join dialog box from the assemble panel. Click here, then choose join tool from the assemble panel. Select the cylindrical surface of bar globe and circular edge of the screw bar. Rotate the assembly with the help of V cube. Then select this face of bar globe. Now click on the home button. Now click on select button in the snap area. Then choose this edge of the jaw screw. Choose the rigid option from the type drop down list of the motion tab and then choose the OK button in the dialog box. Click on the motion tab, then select rigid option from the type drop down list and now click on the OK button. Similarly, apply rigid joint between the second bar globe and the other end of the screw bar. Similarly, apply the rigid joint between the second bar globe and other end of the screw bar. Click here, then choose joint tool from the assemble panel. Then select this face. Now rotate the assembly with the help of V cube. Click on the select button in the snap area and then select this edge. Now click on the motion tab and make sure that rigid option should be selected in the type drop down list. Click on the OK button. Now choose the home button from the graphics window to get the isometric view of the assembly. Invoke the new context set dialog box and select the screw bar, jaw screw and both bar globes from the browser bar to create contact sets between them. Click here, then choose new context set option from the assemble panel. New context set dialog box is displayed. Then select screw bar, jaw screw and both bar globes from the browser bar. Choose the OK button from the dialog box. Click on the OK button. Assembling the clamping plate. Next, you need to assemble the clamping plate with the assembly. Insert the clamping plate in the assembly and reposition it in such a manner that there is no overlapping between the components of existing assembly. Right click here, then choose insert into current design. Now with the help of manipulator, you have to reposition the clamping plate. Now click on the OK button. Invoke the join dialog box. Click here, then choose join tool from the assemble panel. Next, select the circular edge of the hole of clamping plate and also the inner circular edge of the hole in the Y jaw. Select the circular edge of hole of clamping plate. Now rotate the assembly with the help of the V cube and then select inner circular edge of the hole in the vice jaw. Choose the rigid option from the type drop down list of the motion tab and then choose the OK button in the dialog box. Click on the motion tab and make sure that rigid option should be selected in the type drop down list. Now click on the OK button. Choose the home button from the graphics window to get the asymmetric view of the assembly. Assembling the screw 1. Insert screw 1 in the assembly and reposition it in such a manner that there is no overlapping between the existing components of the assembly. Right click here, then choose Insert into Current Design from the shortcut menu. Now with the help of manipulator, you have to reposition the screw 1. Now click on OK button in the move or copy dialog box. Choose the joint tool from the assemble panel. The joint dialog box is displayed. Click here, then choose joint tool from the assemble panel. Select the circular edge of screw 1 and circular edge of hole of clamping plate by rotating the assembly using V cube. Select this edge of screw 1. Now rotate the assembly with the help of V cube and select this edge of clamping plate. Choose the rigid option from the type drop down list and then choose the OK button from the joint dialog box. Click on motion tab and then make sure that rigid option should be selected in the type drop down list. Click on the OK button. Click on the home button to get the isometric view of the assembly. Similarly, assemble screw into other hole of clamping plate. Similarly, you have to assemble another screw into the other hole of clamping plate. Again right click here, then choose Insert into Current Design. Reposition the screw with the help of manipulator. Now click on OK button in the move or copy dialog box. Click here, then choose joint tool from the assemble panel. Now select this edge of screw. Rotate the assembly with the help of V cube. Then select this edge of hole of clamping plate. Now click on OK button. Choose the home button from the graphics window to get the isometric view of the assembly. Assembling the base plate. Now you need to assemble the base plate with the base. Insert the base plate in the assembly and reposition it. Right click here, then choose Insert into Current Design. Now you have to reposition the base plate with the help of manipulator. Now click on OK button from the Move or Copy dialog box. Select circular edge of the hole in the base plate and circular edge of hole of base by rotating the assembly using V cube. Click here, then choose Joint tool from the assemble panel. Then select the circular edge of hole of base plate. Now select the circular edge of hole of base. Choose the rigid option from the type drop down list of the motion tab and then choose the OK button in the join dialog box. Click on motion tab, then make sure that rigid option should be selected in the type drop down list. Click on the OK button. Choose the home button from the graphics window to get the isometric view of the model. Similarly, apply rigid joint between the other circular edge of the hole in the base plate and base of the assembly. Similarly, you have to apply rigid joint between other circular edge of the hole of the base plate and base of the assembly. Repeat the procedure for applying rigid joint for the another instance of the base and base plate. Here you can see that similarly I have assembled base plate with the base of the assembly. Assembling the screw 2. Insert screw 2 in the assembly and invoke the joint dialog box from the assemble panel. Click here, then choose insert into current design option from the shortcut menu displayed. Reposition the screw 2 with the help of manipulator. Choose the OK button from the move or copy dialog box. Click on the assemble tab, then choose the join tool from the assemble panel. Join dialog box are displayed here. Select circular edge of screw 2 and circular edge of hole of base plate by rotating the assembly using VQ. Select the circular edge of screw 2 and then rotate the assembly with the help of VQ and select the circular edge of hole of base plate. Choose the rigid button from the type drop down list of the motion tab and then choose the OK button in the join dialog box. Click here, then choose rigid option from the type drop down list and click on the OK button. Now click on home button to get the isometric view of the assembly. Similarly, assemble the other instances of the screw 2 with the base plate. Similarly, you have to assemble other 3 instances of screw 2 to the base plate. Here you can see that after assembling all the components of the bench-wise assembly, the assembly will look like this. Analyzing the assembly for interference. Choose the interference tool from the inspect panel. Click here, then choose interference tool from the inspect panel. Here you will get message. Do you want to capture the current position of moved component or revert components to their previous position? Click on the capture position. Now you can see that interference dialog box are displayed here. Select the include coincident faces checkbox. Select the include coincident faces checkbox from the interference dialog box. Select the components of bench-wise assembly from the browser bar and choose the compute button from the interference dialog box. The interference results dialog box are displayed. Select the components of bench-wise assembly by pressing Ctrl key from the browser bar. Now click on compute button. Interference result dialog box are displayed here, showing the interference of the component in the assembly. Now click on OK button. Saving the assembly. Next you need to save the assembly. Choose the save option from the file menu or application menu. The save dialog box is displayed. Click here, then choose save option from the file menu. Save dialog box is displayed here. Choose the OK button from the dialog box. Click on the OK button. Now your assembly gets saved in the data panel. Thank you for watching this video.